In his 1915 General Theory of Relativity, Albert Einstein characterized gravity as the bending of spacetime. This was the prevailing understanding of gravity for the next 100 years. Music. However, now a new theory has been proposed that could change everything we know about gravity. The advanced gravity hypothesis suggests that gravity isn't a force but rather the result of the curvature of spacetime. If this new hypothesis is correct, it could mean a complete overhaul of our understanding of physics. So far, it has been met with much skepticism, but the researchers who proposed it are convinced that it is the right answer. Watch, like, and comment on this groundbreaking revelation that challenges physics. Gravity isn't a force. What do you think? Is this new hypothesis correct, or is it just another fringe idea? The foundational history of gravity. Albert Einstein introduced his theory of general relativity in 1915, arguing that gravity was not a force but rather a consequence of the curvature of spacetime. Einstein's general theory of relativity remains the most influential and widely accepted explanation of gravity. This theory describes how the effects of gravity influence objects in reality. It is based on the idea that gravity is not a force in the traditional sense but the result of how mass curves spacetime. Einstein's groundbreaking work has profoundly influenced our understanding of the universe, leading to the discovery of black holes and the universe's expansion. While Newton's theory of gravity is still accurate in many contexts, general relativity has provided a more comprehensive framework, especially for large-scale phenomena like planets and galaxies. How we used to think gravity worked. For centuries, gravity was considered a force. Isaac Newton described gravity as an attractive force between masses, and this idea was taught for generations. However, Einstein's insights revealed that gravity might not be a force at all. Instead, it's a result of the curvature of spacetime caused by massive objects. While Newton's laws work well for slow-moving objects or those near Earth, they fall short when examining phenomena on a cosmic scale. Why the new discovery of gravity changed physics? When we think of gravity, we picture a force pulling objects down. But what if gravity isn't a force at all? Physicist John Dalton's relatively new insight re-examined this assumption, revealing that gravity is actually a result of the attraction between masses due to spacetime curvature. This revelation shifted how we view physics and opened the door for further discoveries. How researchers made this discovery. This new understanding of gravity began with Einstein's mental experiments. He proposed that gravity is the bending of spacetime, meaning that mass creates curves in the fabric of spacetime rather than exerting a force. Imagine spacetime as a rubber sheet. Place a bowling ball on the sheet. It bends around the ball. Now, roll a marble across the sheet. The marble follows the curvature created by the bowling ball, mimicking the effects of gravity. If a second bowling ball is placed nearby, the curvature intensifies. This is because both masses contribute to the bending of spacetime. Einstein's realization was that objects fall not due to a pulling force but because they follow the natural curves of spacetime. What this means for theoretical physics. If gravity isn't a force, then there are still fundamental aspects of the universe we don't yet understand. This idea is exciting for physicists, as it means there is much more to discover. Einstein's theory has already led to groundbreaking revelations, like the existence of black holes. Yet, questions remain about the exact nature of spacetime and what might lie beyond our current understanding. Implications for our everyday lives. What does this mean for us? It changes how we conceptualize gravity, not as a force pulling us down but as the result of spacetime's curvature caused by massive objects like Earth. This shift in perspective deepens our appreciation for the intricacies of the universe. And while it might not affect us directly in daily life, it opens up new possibilities for exploration and discovery in physics, ensuring the journey of understanding our universe continues. In his 1915 General Theory of Relativity, Albert Einstein characterized gravity as the bending of spacetime. This was the prevailing understanding of gravity for the following 100 years. Music. However, a new theory has now been proposed that could change everything we know about gravity. The digital gravity hypothesis suggests that gravity isn't a force but rather the result of the geometry of spacetime. If this new hypothesis is correct, It could mean a complete overhaul of our understanding of physics. So far, it has been met with a lot of skepticism, but the scientists who proposed it are convinced that it is the right answer. Watch, like, and comment on this new discovery that could change physics forever. Gravity isn't a force. What do you believe? Is this new hypothesis correct, or is it just another far-fetched idea? The foundation of gravity. Albert Einstein introduced his theory of general relativity in 1915, arguing that gravity was not a force but rather the result of the curvature of spacetime. Einstein's general theory of relativity describes gravitational forces and their effects on objects in the universe. The theory is based on the idea that gravity isn't a force at all. Instead, gravity is a consequence of the curvature of spacetime. Einstein's theory has had a profound impact on our understanding of the universe, particularly in leading to the discovery of black holes and the expansion of the universe. Although general relativity is widely accepted, it isn't the only theory of gravity. For example, Newton's law of gravity is still taught, though it is limited in scope. Einstein's theory remains the most prominent and accepted framework. For centuries, scientists tried to understand the nature of gravity, and Einstein's theory finally provided an answer. Since then, general relativity has been proven repeatedly through observations and experiments, becoming one of the most reliable theories in physics. How we used to believe gravity worked. Most people think of gravity as a force, something pulling objects downward. This has been the way gravity was described in physics for centuries. Isaac Newton defined gravity as a force between masses, and it was taught this way in schools for generations. But what if gravity isn't a force at all? What if it's just an effect of the curvature of spacetime? This is the theory physicist Einstein proposed over a century ago, and it has gained traction in the scientific community in recent years. Newton's law of gravity is accurate in limited contexts. It works well for objects moving slowly or near Earth. However, it falls short when we examine things on a larger scale, such as planets and galaxies. Why this new discovery of gravity could change physics? When you think about gravity, it's likely the first force that comes to mind. After all, it's what makes things fall. But what if gravity isn't a force? That's what physicist John Dalton suggested in his groundbreaking discovery. For years, scientists operated under the false assumption that gravity was a force. However, Dalton realized that gravity is actually a result of the attraction between masses. This revelation altered how we view physics and paved the way for future discoveries. It was a pivotal moment in the history of science, all sparked by one person asking the right questions. How scientists made this discovery. So how did scientists arrive at this understanding? It all began with a thought experiment. Albert Einstein conceived the idea of gravity as the curvature of spacetime. This means that gravity results from the way mass bends spacetime rather than acting as a force. To understand this, imagine spacetime as a rubber sheet. Place a bowling ball on the sheet, it will cause the rubber to curve around it. The bigger the ball, the more it bends the rubber. If you roll a marble across the sheet, you'll see it curve as it approaches the bowling ball. This is because the gravity of the bowling ball bends the spacetime around it. Now, place a second bowling ball near the first. The spacetime will bend even more. The greater the mass, the more spacetime curves. Einstein realized that objects fall not because of a force pulling them down but because they follow the natural curvature of spacetime. This realization fundamentally changed our understanding of gravity. It also led to major discoveries, such as the existence of black holes. What this means for theoretical physics. In the past, gravity was seen as a force pulling things together. If gravity isn't a force, then what is it? Some scientists believe it's the result of spacetime's curvature. Rather than being drawn toward something, objects follow the natural curve of the universe. This is the essence of Einstein's general relativity, proposed in 1915. While widely accepted by the scientific community, there's still much we don't know about gravity. If gravity isn't a force, it suggests there are other aspects of the universe yet to be discovered. For physicists, this is exciting because it means there's still so much more to learn about our universe. Implications for our daily lives. So, what does all of this mean for us in our everyday lives? For starters, It changes the way we think about gravity. It's not a force pulling us down but the curvature of spacetime caused by massive objects. What does this mean for how we live our lives? It means we don't have to worry about things falling on us because of some mysterious force. Instead, objects fall due to the natural curvature of spacetime. This may seem like a small distinction, but it represents a significant shift in how we understand the world around us.